Hello everyone. Today's webinar is going to be on Module 6, Hydronics 1.1 through 1.3, Week 1, Day 2, Basics of Hot Water and Steam Heat. Introduction to Hydronics, Basics of Hot Water and Steam Heat. Define the following words to help clarify basic of hot water and steam heat. Hydronics, steam boiler, hot water boiler, radiators, thermodynamics, thermodynamic laws, conduction, convection, radiation, heat loss, heat transfer, heat, heating ducts, heat register, circulator pump, boiler sight glass, boiler relief valve, heat dissipate, thermal radiation, temperature. Introduction to Hydronics. Hydronics in simplest terms, today hydronic heating is an energy efficient home heating system that uses tubing to run a hot liquid beneath the floor along baseboard heaters or through radiators to heat your home. Common examples: hot water boilers, steam boilers. Introduction to Hydronics. Hot water boiler. Hot water boiler is central heating by means of hot water circulated through pipes or radiators. Introduction to Hydronics. Steam boiler. Steam boilers, a vessel in which water is boiled to generate steam to produce heat. Introduction to Hydronics. Thermodynamics. Steam and hot water boiler uses thermodynamics to heat a home, building, etc. Thermodynamics, the science of heat, which is used to produce a heating system. Thermodynamics law. First law, heat cannot be destroyed. Because heat is a form of energy and energy can't be destroyed. Heat energy is the result of the movement of tiny particles called atoms. Heat can only dissipate, which means it only changes form. Second law, heat is transferred in one direction if there is temperature difference from warm to cool direction. This is the act of heat dissipating, which can be done through many methods. The three basic ways of heat transfer is as follows: conduction, convection, radiation. Introduction to Hydronics. Thermodynamics. Conduction. The transfer of heat across a medium from a source of higher temperature to a source of lower temperature, which allows heat to dissipate throughout a material and possibly into different material that is contact with hot material. An example is an electric stove top that is heated through electrical resistance. Convection. The circular movement caused by difference in weight as a result in temperature change. Transfer of heat using a liquid, which is a transfer of heat through moving fluids. An example of this could be convection oven that uses air, the fluid, to transfer heat. Radiation. The heat leaving a heated object in which heat is dissipated through electromagnetic waves. The type of heat dissipation is illustrated by people sitting around a campfire and warming their hands over it because of the heat radiation from fire. Introduction to Hydronics. Boiler versus forced air furnace. A boiler has water, which we heat up in order to create heat. A furnace has air that we force past a heat exchanger in creating warm air. A boiler has pipes in which the water flows through. A furnace has ducts in which the air flows through. A boiler has radiator that releases heat A furnace has vents and registers that releases the air. A boiler has circulating pump to help us circulate the water through the system. A furnace has a blower motor to help circulate the air. The good and bad between a boiler and a furnace. A boiler has no air conditioning. A boiler can be zoned. A boiler can go up to 9 million BTUs, but a boiler cannot treat the air. A boiler continues to heat the unit until the boiler cools off. A furnace has air conditioning, but a furnace cannot be zoned. A furnace nowadays can only go up to about 120,000 BTUs. But a furnace can treat the air. Introduction to hydronics. Hot water boiler versus steam boiler. A hot water boiler has all water, no air. If you have any air, it can possibly stop the flow of the water. The hot water boiler operation pressure is from 12 psi to 18 psi. If it goes over the 18 psi, you run the risk of your pressure relief valve popping. The hot boiler has a circulating pump for circulating water, and it also has copper pipes and black iron pipes in which the water flows through. It has temperature controls to regulate the temperature, and it has a pressure relief valve that releases at 30 psi. The steam boiler has a sight glass in order for you to see the level of the water inside of the boiler. The operational pressure is less than 2 psi. No circulating pump. You cannot use copper piping. You must use all black piping. It also has temperature controls, but the pressure relief valve opens up at 15 psi. It is gravity fed, so once the water has turned into steam, the steam rises up and then it goes to the radiators. Some water, some air. And it does have pressure controls.